All right, let's start this lesson with a review of the derivatives we actually know how to take. We're well underway into learning how to do integration, but for this one we're going to step back a little bit and talk about derivatives. Now really you only know 7 rules as far as the types of functions you can differentiate. And if you consider the 6 trig functions to be one type, you really just know 2 styles. You can differentiate powers, so polynomial functions, or rational functions like x to the negative 2, 1 over x squared, and you can differentiate the 6 trig functions. We, of course, have chain rule and product and quotient rules, which let us combine these ideas and expand the actual functions you can differentiate, but at the base you really only know these 7 things. And we're going to add to that with this video. Okay, so we're going to specifically talk about exponential and logarithmic derivatives. So exponential, like e to the x, or it could be another base like 2 to the x, looks like this. They all go through without, unless they've been shifted up, down, left, right, they go through the point 0, 1. And they have this really steep incline as we move left to right. A log is the inverse of exponential. They go through 1, 0. And they have this steep turn to the right. They never go on the left side of the graph. The y-axis is an asymptote, as opposed to over here the x-axis is an asymptote. So that's just to get fresh in your mind what these graphs look like. And now for the derivatives. The derivative of natural log of x is pretty simple. The derivative of natural log of x is 1 over x. Okay, so that's just one you're going to use a lot, you're going to get familiar with. Technically, we really just need to know the derivative of the natural log of u because it involves the chain rule, and if you know it, you know the natural log of x, but it's 1 over u, as similar to the natural log of x formula, times du dx. This is the chain rule. But a shorter way to say this is it's u prime over u. So if you want to take the derivative of the natural log of some function, the answer is that same function on the bottom and that function's derivative on top. So for example, the derivative of the natural log of x squared plus 1. The function x squared plus 1 goes on the bottom, and the derivative of the function 2x goes on top. And that's all there is to it. And if you have something like this next one, the natural log of the square root of x plus 1, because of the rules of logs, which you have to remember from your Algebra 2 or pre-calc days, let us manipulate the way logs look. Remember, the log, natural log, or some other base of x squared is the same as 2 times the natural log of x. This is why logs are helpful for solving exponential equations, because they drop exponents down to the front of the expression. So if you can make life simpler on yourself, rewrite using the rules of logs. Rewrite this function as 1/2 natural log of x plus 1. Because really, this square root is a 1/2 power. So I could think of it as x plus 1 to the 1/2. And then my log rule says I can drop that 1/2 all the way out into the front of the natural log expression. And so when I put all that together, the 1/2 just becomes part of my answer, and the derivative of natural log is du over u, and the function is x plus 1, and the derivative of the function is 1. So if I put those things together, I get 1 over 2x plus 2 if I go ahead and distribute the 2. So first main rule is this one, and like I said, you don't have to consider these as 2 separate rules, because if the argument of log happens to be just x, then the chain rule is not going to show up. It's just going to be times 1, but that's going to happen because u prime will just be 1. So remember this one that is circled over here in red for sure. Okay, so that was natural log, and probably 90% of the logs that you have to differentiate will be natural logs, but don't forget logs can be of any base. And what we learned on the other one was the derivative of natural log was 1 over x. Well, the derivative of some other log base is also 1 over x right here, but because it's not natural log, we have to throw in the natural log of that base down here. And if you think about it, the base of natural log is e, and the natural log of e is 1, so if we did this for a natural log, this part would be 1 and it would just kind of go away. And again, you don't have to memorize both of these. This is the one over here on the right that really matters, because if the chain rule doesn't apply, then you're back on the left one, but you don't have to think about that beforehand. If the derivative is 1, the derivative is 1. So the derivative of the natural log of, or excuse me, the log base a of u is u prime over u, but we have to insert this little natural log of the base into the denominator. So this first one, derivative of log base 3 of x, overall I'm thinking 1 over x, because the derivative of a log is 1 over x, or u prime over u. And in this case, u prime happens to be 1. Since it's base 3, natural log of 3 goes in the denominator, and that's it. And that's not really spaced very well. Natural log of 3 times x, and that's it. Again here, log base 5 of the square root of x squared minus 1. I didn't point it out this time, so hopefully you're thinking this. Cheat. It's much easier to take derivatives of things like x squared minus 1 than it is to take derivatives of the square root of x squared minus 1. So get that 1/2 out to the front of the log expression before you ever start. And now apply the rule. The 1/2 is a constant, so it's going to be part of my answer. And the derivative of log base 5 of u, we're using this right here, is u prime over u with an extra little natural log of 5 in the denominator. U prime over u, let's see, that's the function on the bottom, x squared minus 1. The derivative of x squared minus 1 is 2x. The 2's can cancel, and that pretty much leaves the answer x over natural log of 5, x squared minus 1, and that's it. Alright, so those are our two log derivatives, natural log in bases other than e, and let's move on to this. So the inverse of log is exponential. We talked about those graphs at the beginning. This first rule is, I think, pretty amazing. The derivative of e to the x is e to the x, the easiest formula in all of calculus. And what's really cool about it is, think about the function e to the x is shown here in red. The derivative of e to the x is the slope of the tangent line to that function. So what that means is wherever I go on this graph, right here, my height is 1. Well, my tangent line slope is also 1. If I go over here to 5, or height of 5, if the value is 5, then the slope of the tangent line is 5. And that's just interesting to me, I think, maybe not to everybody, but the value and the slope of e to the x are always the same, no matter where you go. As you move out down here, I have a very small positive value. Right, I'm above the axis, but I have a tiny number, way less than 1, and so is the slope. The slope is almost 0 because it's almost a horizontal line. So that's just interesting, but as far as working problems goes, the derivative of e to the u is e to the u, just like e to the x becomes e to the x. But if u has a derivative of its own, then the derivative of e to the u is e to the u times u prime. So you literally just copy the question again, e to the negative 2x plus x squared, and then you apply the chain rule, negative 2 plus 2x. This is the derivative because e to the u du. The exponential derivatives and integrals are the easiest rules that we'll do pretty much all year. E to the u is e to the u, just tack on the chain rule. Alright, so like I said, 90% of the time we're going to be dealing with e's and natural logs, but we'll also deal with other exponential expressions and other logs with different bases. So with a derivative of log, we had to tack on a little natural log in the denominator. With the derivative of an exponential, like a to the x, the answer is a to the x, just like it was with e, but you tack on the natural log of that base. okay? And once again, we really just need to know the one about u because it includes the chain rule. The derivative of an exponential expression, a to the u, is a to the u prime for chain rule, natural log of a, because the base is other than e, okay? So for this last example, it's got a couple things going on. We're taking the derivative of x times 6 to the negative 2x. So this really is the part that's going to apply to the new rule. But I wanted to do one that made us use one of our old friends, the product rule. We've got two functions, function 1 and function 2. And one of them is going to involve our new stuff, and the first one is not. So when I see a derivative of a product, my first thought is first times derivative of second. So I would write x, that's the first function, times the derivative of the second function. So the derivative of the second function is going to fall under this formula, where a equals 6 and u equals negative 2x. So the derivative is the natural log of a, it's natural log 6, times a to the u, 6 to the negative 2x, right? For the most part, this is how I remember these. The derivative of something, of an exponential, is itself. We have these other two factors to consider, the chain rule and the natural log, but the derivative of a to the u is a to the u with these other considerations. So back to this u prime, the derivative of u is negative 2. I'm not going to try to simplify too much. Just get everything written out and worry about simplifying later. Get the derivative taken and then go back and worry about simplifying it. So this is just the first part of my product rule. That was first times the derivative of second, plus the second, which is 6 to the negative 2x, times the derivative of the first, which is just 1, because the derivative of x is 1. And there are some things I can do to simplify this. I can factor out, if I could factor out the 6 to the negative 2x that they have in common. An answer in the back of a textbook would probably do that, so let's just do that to see what it would look like. 6 to the negative 2x they have in common. Now if I factor that out of this first term, I'm left with an x, a log 6, and a negative 2. So let's call that negative 2 natural log 6x, and then plus 1, because 1's all that's left over when I take out that 6 to the negative 2x. So long story short, that's the derivative using the product rule and using our last new rule of the day.